Imagine that our entire world is just a complex program, a virtual matrix controlled through the vast expanses of time and space. Google's super-powerful quantum chip suggests that reality as we know it, perhaps no more than an illusion. Today we will reveal fascinating secrets that question the very essence of human existence. Are you ready to look behind the digital curtain and realize that everything you thought was real, it might be nothing more than a carefully planned simulation? On December 9, 2024, Google released the Google Willow quantum chip. According to information from ANOSOV, Willow is designed to improve the stability and accuracy of qubit operations, as well as to reduce the error rates in quantum computations, which have long been a major issue. Improving this metric is critically important for making quantum computers more efficient and capable of solving problems that are impossible for classical computers. Willow can solve a problem in less than 5 minutes. Solve a problem that a supercomputer would take 10 septillion years to handle. That's 10 to the 25th power. For comparison, the age of the universe is about 13 billion years, or 13 to the 10th power. Hartmut Nevin suggested that the Willow quantum chip's performance indicates parallel universes. It might use information from these universes. He believes the chip's speed suggests that quantum computing could span multiple universes. In other words, the chip uses information from parallel universes for its calculations, thus achieving incredible speed. This idea sparked heated discussions in the scientific community. Some scientists enthusiastically embraced this hypothesis, seeing it as confirmation of the multiverse theory. Others approached it with caution, noting that there is currently no experimental evidence for the existence of parallel universes. During testing of the chip, the researchers obtained results that surpassed any classical calculations. The task took 5 minutes to complete instead of 10 septillion years for the most powerful supercomputers. Hartmut Nevin connected results to David Deutsch's multiverse theory. The chip's power supports quantum computations across universes. Chip power shows quantum computations in the chip, confirms the concept that quantum computations occur in many parallel universes. This conclusion actually supports the hypothesis that our reality could be a complex computer simulation. Quantum computing, using superposition, challenges reality by processing vast data instantly. Challenges our established notions of reality. This ability to process an enormous amount of data almost instantaneously. And that very moment raises the question, are we ourselves just in a superposition? This event, aside from the obvious technological breakthrough, made us think about deeper aspects of our reality. Why do such possibilities arise at such a specific moment in history, when the world can't exist not only without the internet but now also without neural networks? Maybe all of this is part of a carefully planned simulation that we're living in. What is the multiverse theory by physicist David Deutsch that Nick Bostrom refers to? Deutsch is one of the creators of the concept of quantum computing. Deutsch's parallel universes link to many worlds in quantum. It's closely tied to the interpretation of quantum mechanics, the many worlds interpretation, one of the main ideas behind parallel universes. First idea is many worlds, or MWI. According to the MWI, when a quantum measurement occurs, there is no collapse of the wave function. Instead, the universe splits into several branches, each corresponding to different possible outcomes of the measurement. So, all possible outcomes of a quantum measurement are realized, but in different world branches. Second idea, multiverse. In this interpretation, there are an infinite number of parallel universes, each reflecting different outcomes of quantum events. In parallel universes, a person might make different choices without any interaction between them. These universes exist in parallel, and there is no interaction between them. The third idea is Deutsch quantum computing. Deutsch's work links quantum computing and many worlds, showing how computers process outcomes in parallel. He develops MWI ideas, suggesting quantum computers use parallel universes. He argues that quantum computers can effectively use parallel universes for computations because in each branch, there's the possibility of processing information considering all possible outcomes. The fourth idea is coherence and interference. A key aspect of the MWI is the coherence of all possible states. In quantum mechanics, when particles or states interact, interference can occur, which is observed as a result of mixing different branches of reality. Deutsch argues that this phenomenon allows the many worlds interpretation to provide a more complete and consistent explanation of quantum effects than traditional interpretations. And the fifth, practical significance. Although the many worlds interpretation is quite theoretical and lacks direct experimental confirmations, it offers interesting conceptual approaches to explaining quantum processes and may potentially be used to develop new theories in the field of quantum computing. Is our reality the product of a carefully planned simulation? This intriguing hypothesis was developed by philosopher Nick Bostrom, who argues that advanced civilizations might create such consciousness simulations that are indistinguishable from real life. In recent years, this theory has been getting more attention thanks to advancements in quantum computing, and, in particular, the development of the Sycamore quantum processor, which was also released by Google. The processor was released in 2019, long before the introduction of the Willow chip. Sycamore became well known for achieving quantum supremacy, the first demonstration that a quantum computer can solve a problem inaccessible to classical supercomputers. Sycamore uses 54 qubits to solve a random sampling problem, which showed that quantum computers can perform some calculations faster than their classical counterparts. Willow was introduced later and is designed for other, more complex and practical tasks in the field of quantum computing, such as improving algorithms for quantum computing, simulating molecules and materials. Willow has more qubits, 72, and is more scalable. Sycamore was aimed at demonstrating the concept of quantum supremacy. Willow is being developed as part of a longer-term effort to create quantum systems that can tackle real scientific and engineering challenges. Overall, Sycamore was a step toward proving the concept of quantum supremacy, while Willow represents a more scalable and potentially more practical platform for future quantum computing. The simulation argument by philosopher Nick Bostrom is based on three main theses. It is highly likely that humanity will go extinct before reaching a post-human phase. Second, each post-human civilization is extremely unlikely to run a significant number of simulations of its evolutionary history or its variations. Bostrom, we almost definitely live in a computer simulation. Bostrom considered this thesis to prove it. The modern vector is aimed at actively developing digital technologies, artificial intelligence, nanotechnology, and many other fields. In his view, humanity will be able to develop them to such an extent to have enormous computing power and simulate the workings of many intelligent beings. In recent decades, there has been a sharp increase in computing power. We're creating increasingly complex virtual worlds and simulations, ranging from video games to modeling entire ecosystems or even physical processes. If this trend continues, there's a chance that in the future, we could create simulations that are so realistic that they will be indistinguishable from reality. With the development of virtual worlds and metaverses, like games such as The Sims or virtual reality, where life simulations are created, it becomes clear that such systems could reach a level of complexity close to reality. If we can create such worlds, then it's quite possible that some highly advanced civilization could create a simulation that will be different from the real universe, only by the fact that it is programmed. In physics, there is a hypothesis that space-time could be discrete at very small scales. Planck length. This means that the universe could be made up of tiny units, like an image made of pixels. If that's the case, maybe our world is something like a virtual reality, where space and time have minimal units. Just like in computer graphics, an image is made up of pixels. In quantum mechanics, there's an effect where the state of a particle depends on whether we observe it or not. It's kind of like in video games. Objects activate when looked at, when the player's gaze is directed at them. This phenomenon can be interpreted as a possible glitch in the simulation, where the act of observation affects reality. The universe can be described mathematically. Theories are expressed mathematically, similar to programming code. For example, many physical theories, like the theory of relativity and quantum mechanics, can be expressed through mathematical formulas that resembles the structure of programming code. It's believed that if our universe is a simulation, then it must be written in the form of mathematical code. There are a few examples of glitches in the system seen as potential evidence we are living in a simulation. First example is Mandela effect. People remember things differently than they were. For instance, they recall the KitKat logo with a hyphen, though it's always been KitKat. For example, people remember the KitKat brand logo with a hyphen as KitKat, although officially the logo was always written without the hyphen as KitKat. A few people might be sure that a certain object is depicted in a famous painting. In painting of Mona Lisa, there's a smile or facial expression that doesn't actually exist, or people remember certain historical facts differently. Such anomalies can be interpreted as changes in the simulation's database, where the original data has been randomly altered or reprogrammed. Many paranormal phenomena such as ghosts, UFOs, and other supernatural phenomena can be seen as glitches in the simulation's software code. For example, some people claim to have seen ghosts or entities. That can't be explained by modern science. UFO sightings, seen as unexplainable events, might be glitches in reality. These phenomena might be glitches in reality. UFO sightings and visual anomalies may be glitches in reality. They can also be seen as elements that don't fit into our existing reality and may be glitches in the simulation. Unexplainable visual anomalies occur. Some report strange object or light behavior. For example, you might be looking at an object, and it suddenly starts to disappear or change when you're not looking at it. Some people claim that objects or light behave oddly, like sudden brightness in the sky. For example, when the sky or surrounding objects suddenly become unusually bright, as if it were part of some test or program. String theory suggests particles are strings vibrating in patterns. These vibrations generate new particles. They're not points, but strings vibrating in specific patterns. In the process of this vibration, unlike musical strings, they don't produce sound but instead generate new particles. String theory suggests diverse space-time structures based on extra dimensions. Universes may have varying physical laws and constants. This means that there could be universes with different laws of physics, where constants can differ significantly from those we observe in our universe. These universes form a multiverse with unique properties from those we observe in our universe. These universes could make up a multiverse, each with its own unique properties. String theory suggests the possibility of multiple universes, each with unique properties, arising from different solutions to extra-spatial dimensions, each of which could be the result of different solutions for how the extra dimensions of space are structured. The simulation hypothesis challenges humanity. Quantum technology blurs reality and virtuality. It becomes not just a scientific hypothesis, but a challenge to humanity. Quantum chips and processors are lifting the veil, showing us that the lines between reality and virtuality might be illusory. Our actions, freedom of choice, and even our understanding of existence are being closely scrutinized. Perhaps we are just on the brink of the greatest discovery of our time. Who created our existence? And what awaits us next? And I have an interesting proposal for you. You have a unique opportunity to become part of our team. If you have video editing skills, you can voice videos in Russian, English, and other languages. Or do you write interesting scripts? We would be happy to work with you. Message our Telegram bot. Link in description. That's all for today. Thank you for watching.